Hi guys, I hope that you're all doing well. In today's lesson, we'll learn how to use the gradient formula in grade 10 analytical geometry. Find the gradient of the following points and state whether it's a positive slope, negative slope, or horizontal. So for the first question, we have point A and point B. Under A, we have -1 and 3, and under B, we have 2 and 9. So let's start by labeling our points. A will be our first point. Let's write our 1, and B will be our second point. So for A, we have -1, which is your x, and 3, which is your y. They all fall under point 1, so this should be x1 and y1. For B, we have 2 and 9. This 2 is your x, and that 9 is your y. They're all under point 2, so this should be x2 and y2. Let's substitute into our gradient formula. There's your formula. We have m, a small m, is equal to y2. Where's y2? There it is, it's 9. You have minus y1. That should be minus, where's y1? There it is, it's 3. All over, you have x2. Where's your x2? There's your x2. It's 2 minus x1. x1 is -1, so this should be in a bracket, -1. Now let's punch this in a calculator, and your answer should be, you still have to write down this m is equal to 2. So you now know the gradient of point A and B. They also said, state whether it's a positive slope, negative slope, or horizontal. Okay, when you have a slope that goes upwards, meaning let's say from here to there, know that it's a positive slope. And when it goes downwards from, let's say here to there, it is a negative slope. And when your gradient is 0, that means it's perfectly flat or horizontal, as they've said there. So if your gradient is 0, that means it's from here to there. Now we have m is equal to 2. It's positive, so that means it's a positive slope. It goes upwards. Now let's say positive slope, because it has a positive gradient. The gradient is greater than 0. Okay, now let's do a few more examples. For number 2, we have points C and D. Let's start by labeling our points. C will be your point 1, and D will be your point 2. We have 4, which is your x value, and -2, which is your y coordinate. So this should be x1 and y1. For D, we have -2, which is your x, and 1, which is your y. It should be x2 and y2. For the next step, let's substitute into our gradient formula. We have m is equal to y2. There's a y2. It's 1 minus y1, which is -2. Let's put it in a bracket all over. You have x2. There's your x2. It's -2 minus x1. x1 is 4. So it's -2 minus 4. Now let's punch this in a calculator without making any mistakes. Make sure that you include your bracket. Your answer should be, you write our m is equal to -1/2. That is the gradient. It's -1/2, meaning it's negative. So is it a positive slope, negative slope, or horizontal? Our answer is negative, meaning it's smaller than 0. It slopes downwards, let's say from here to there, or from here to there. Okay, excuse me, from here to there. It slopes downwards, so this is a negative slope because our value is negative. So we represent this by using smaller than 0. Now let's do the last example. We have points E and F. Let's label our points. E is your first point, and F is your second point. You have 0, which is your x, and -5, which is your y. They are under point 1, so this should be x1 and y1. For the second point, we have x, we also have our y. So this should be x2 and y2. Now let's substitute into our formula. This should be, we have m is equal to y2 your y2 is negative 5, minus y1, which is negative 5, all over, you have x2 is 3, minus x1, which is 0. Now let's punch this in a calculator. Negative 3 minus negative 5, all over 3 minus 0. That means m is equal to 0. Now let's answer the second part of the question. Is it a positive slope, negative slope, or horizontal? Our gradient is 0. Okay, so that means it's perfectly flat, or it's a horizontal. Because m is equal to 0. It's from here to there. Now let's try the last few examples where we're not only given points, but we have to determine our coordinates using a graph. Find the gradient of the following points. This graph shows a line rising from left to right, passing through points J and K. That is your J and that is your K. We have to find the gradient. In this case, we don't have the coordinates, however, we have a graph that will help us to determine the coordinates. Let's start with K. For K, we have negative 4. Before we find the coordinates, remember that is your x-axis and that is your y-axis. So here at this point, we have 4. That means it's your x. Okay, it comes first, you write our 4. Now let's look at our y-axis. We have 1, so that means it's your y value. Therefore, the coordinates of K are 4 and 1. Now let's look at J. For J, there's your point. Let's determine our x-axis, negative 2. That is your x-axis. So negative 2, what is your y value? We have negative 3. So the coordinates for K are 4 and 1. The coordinates for J are negative 2 and negative 3. We have our coordinates, that means we can find our gradient. Remember, the formula is small m is equal to y2 minus y1. Make sure that you memorize these formulas. All over x2 minus x1. Now let's label our points. For K, we can use this as our first point. We have 4, which is your x, and 1, which is your y. So that will be x1 and y1. For J, we have, let's label it as point 2, negative 2, which is your x, and negative 3, which is your y. So that will be your x2, and that will be your y2. Now let's substitute. This will be m is equal to y2. Y2 is negative 3. Negative 3 minus y1. Y1 is 1. All over x2. Where's x2? There it is. It's negative 2 minus x1. X1 is 4. So when you punch this in a calculator, your gradient should be m is equal to 4 over 6. And can you guys see that we have a positive answer? It's greater than 0, right? And I told you that when you get a positive gradient, you have an upward slope. So can you see that it starts from here to there? That means it's positive. However, this can still be simplified. 4 over 6, when you simplify it, you'll get 2 over 3. So your calculator will give you 2 over 3 as your final answer. Find the gradient of the following points. This graph shows a line. This graph shows a line falling steeply from left to right, passing through the points P and Q. So let's use our graph to find the coordinates. For P, there we have 5, but let's remind ourselves, that's our x-axis and that's your y-axis. So for P, we have 5. That means that 5 is your y-axis. It's your y value. Okay, so let's check. We also have negative 1. That is on your x-axis. That means your x should be negative 1. So your coordinates are negative 1 and positive 5. Now let's look at points. The point Q. Okay, For q here, we see that we have 2, which is your x value, and let's see, we have -1 there, and that is your y, -1. So our coordinates are p, -1 and 5, and q, we have 2 and -1. Now let's label our coordinates. This p will be our first point, and that q will be your second point. So here we have 2, which is your x value, and -1, which is your y. They all fall under the second point, so this should be x2 and y2. For the first point, we have -1, which is your x, and your 5, which is your y. So this should be x1 and y1. Now let's substitute into our gradient formula. Remember, m is equal to y2 minus y1 all over x2 minus x1. So you're right, our small m is equal to y2, our y2 is -1. -1 minus y1, y1 is 5. 5 all over, we have x2, your x2 is 2 minus -1, which is your x1. So let's put it in a bracket, -1. So when you punch this in a calculator, your m should be -2. Again, can you see that you have a negative gradient? It's smaller than 0. That means it should be downward slope. So can you see that we went from this to there, from here to there? So that means when your gradient is smaller than 0, when it's negative, it will be a downward slope. And that is how we determine the gradient in grade 10 analytical geometry. Thank you guys for watching. Please like and subscribe. And remember, I'll do more past question papers with you guys to prepare you for your exams.